steps to solve logarithmic equations, but the basic things really is to change them into exponential form. But you cannot change them into exponential form if they are expanded like this. So logically speaking, if they are expanded, you need to condense them in order for you to change them into exponential, or probably could cancel something out in order for you to solve. So in the first example, we don't actually have a problem. We can easily change this into exponential form because you have an ln here. That's a natural logarithm. It means that our base is e. So therefore, our e is raised to -3, which is equivalent to x. All right, and so therefore, you just have to find the value here, but in most cases, this would be enough. But if you are really curious, how much is that? And we can make use of our Desmos graphing calculator to find that. What is the value of E? And so you have E raised to -3, and it's not showing, so that's E raised to, as you can see, that's the approximation for the value of E, which is a constant value equal to 2.72. So raise it to -3. And this is equivalent to approximation to 0.045 or 4.05. So that would be x equals 0.05. And that's the approximation for the value of your x here. Same thing also here. It doesn't have a base, but we know if it doesn't have a base, it's understood that the base is 10. So that's 10 squared equals 3x minus 2. By the way, we're raising it to 2 because we know that the logarithm means exponent. So therefore, it will be equivalent to an exponent. So that will be 10 squared. So after that, of course, we can solve this by raising it to 2. That's 100 equals 3x minus 2. And do everything in reverse to isolate x. So plus 2. And so you have 102 equals 3x. So if you are going to divide this by 3, so your x now will be equivalent to 34. Okay, now the other two examples are different. As you can see, logarithm appears on both sides of the equation. So this is only prompting us to condense our equation. So you remember, if you're adding, we will multiply. Okay, if you are subtracting, we will divide. So of course, this exponent here will be log of x squared is equal to log of 2 multiplied by 3x minus 4. Okay, and so you will have here, if you have a logarithm on both sides, you don't need to change it to exponential form. You just have to cancel it. Okay, and so therefore, this will be x squared equals 6x minus 8. And because this is a quadratic function, we need to isolate, we need to equate it to 0. And so therefore, we don't need 6x and minus 8 on the right side of the equation. You remember our lesson about augmented matrix. If you will move a particular expression to the left or right of the equality sign, you need to change the sign. So 6x becomes negative and 8 becomes positive. Okay, so we can now factor and solve for x. What are the factors of 8, which gives us a sum of -6, and that's x minus 4 and x minus 2. And so therefore, our values of x will be equivalent to 4 and +2. Okay? You can also verify the answer by using y1 equals y2. You still remember? You just have to find the points of intersection of the graph. So if you have our first equation to be 2 log of, using our Desmos graphing calculator, so our first equation is 2 log. So you have your 2 log and you need to find the logarithm. It's actually here. All right, and x. Okay, and the other would be log of 2. Okay, log of 2. Then you have to close the parenthesis. Plus log of 3x minus 4. Log of 3x minus 4. You can actually do this in all sorts of equation. You just have to type y1 and y2, and all you need to do is to find the points of intersection. And as you can see, it intersects at 2.602 and 4.12 something. Okay, so that's the points of intersections in the graph at x equals 2 and x equals 4. You can also do this kind of strategy in other equations. Like if you have here ln x, you have ln x, natural logarithm of x, put that, and then y2 you put negative 3. Okay, and of course you would see that uh, it doesn't accept it, so we have y equals negative 3. You would see that the point of intersection is at 0.05. Okay, so all of your equations can be solved using this strategy by just finding the point of intersection. But still, I'd like you to know the algebraic strategy on how to solve your problem. For example, here, so this is addition. We need to multiply because in college, they might not allow you to use calculator to solve things. So log of 4x, because we have logarithm on both sides, we can just cancel this out. So by distributing x, that is x squared minus x equals 4x. All right. Now, this situation will prompt us to uh, move 4x. It becomes negative, equals 0. So you have x squared minus 5x equals 0. So what you can do here is to factor out by x, and x minus 5 equals 0. Both common factor is x, so you divide each of the expression by x, you will have this left. So therefore, our x is 0 and our x is positive 5. I have to cross out 0. Why is this happening? Why is it that x should be crossed out? Because if you are going to go back to the equation, let's say I'm going to plug it in here. You see, logarithm of 0, there's no way I can get a value of 0 when I'm raising a number to an exponent. Remember that exponential functions are supposed to be asymptotic. It will be approaching 0, but it will not cross it. Same thing also here. If I have 0 here, I have 0 minus 1. That's 0. That's negative 1. And if you raise a number to an exponent, whether you raise it to a fraction, whether you raise it to negative, if you notice, you always get a positive answer. You can never get a negative answer. That's the reason why x equals 0 is an extraneous solution. It's not a solution to the problem. Also, if you're going to graph this in the graphing calculator, you would see that the intersection of the graphs are only at 1 point, which is at 5, 1.301. So therefore, the solution of this problem is only equivalent to 5.